Okay, so the key findings of your recently published Powering Great Britain's Data Centre Ambition report seems to be that a majority of data centre developers significantly underestimate grid connection time. Just, yeah, I suppose a bit of background to why you decided to do the report, and then were you surprised at that finding, if you like?
Yeah, thanks, Phil. I think the reason that we did the report is that we've been, working more extensively with data centers over the last couple of years. And so just for a little bit of background, yeah, we are a grid consultancy business, so we focus very much on trying to help our clients get connected to the grid. So that will cover the sort of technical, regulatory, and commercial type issues, and it's often a combination of those that cause issues for connecting to the grid. And obviously, one of the issues about grid connections is timescale, and the other one's costs. So they're the two main things that developers will look at. And so yeah, we've been noticing a very significant ramp up in data center activity, as I'm sure everyone in the data center community has. And really, we said, right, well, let's try and get some sort of idea about the grid connections side of things. I think in terms of timescales, the data centers have obviously been developed for many years in this country, and there's lots of really great people out there doing data center connections and the grid side of it. But I think what's caught quite a lot of people by surprise recently is just the impact that the wider grid connections queue is having on sort of demand connections. So very specifically, it's the generation and energy projects side of things has caused a massive problem in terms of queue across the country. And over the last sort of 18 months or so, NESO, so the National Energy System Operator, who coordinates connections to the transmission system across Great Britain, they've been running a process to try and reform the connections process to the grid called connections reform, and that has been working through this year. And basically, developers have been seeing increasingly long timescales hitting them coming from that process. So we very much have worked a lot with energy companies, and so to the likes of solar developers, battery energy storage system developers, that sort of thing. They've been seeing these connection delays, connections out to 2037 or beyond for quite a few years, and it seemed to us that some of the data center developers, really knew about this, but others perhaps didn't. So what we wanted to do is do this survey, pick up on some of these issues, and try and shine a spotlight really on some of these issues that are coming through. And I think that's one of the reasons why the sort of our reports really picked up on this underestimation of timescales is really because it hasn't historically been a problem for these sorts of connections, but now it is, and it's really been impacted by things outside of the control of data centers.
Okay, and in terms of the sort of challenges around grid-related sort of data center, aspects, I suppose, things like energy costs and I guess the price volatilities there, the connection process, and maybe infrastructure upgrade. I mean, perhaps you can just describe what's going on. I mean, I imagine also as well there's just a backlog in terms of how people are ready, but the approvals process, if you like, just to get people hooked up to the grid takes a lot of time as well. So just can you give us a flavour of all the obstacles that people might encounter, if that's possible?
Yeah, absolutely. It's a great question, and I think one massive issue for data centers is energy costs. Now, as a business, we don't really get involved in sort of energy costs and stuff. So we're more about grid connections. But everyone knows that the energy costs in this country are very expensive. Some of the most expensive in the world. So that is undoubtedly having a major problem causing a major problem for data centers, and just forecasting that increase in energy costs is I think quite a challenge. For those involved in specifically in that space. Then the other issue with price has been huge price increases for energy connections over the last 3 or 4 years. So everyone's seen big inflationary price increases just from a domestic point of view, but it's been more significant than that for energy projects and large energy projects. So it hasn't been unusual over the last sort of 3 or 4 years to see price increases of 40, 50% or more even on certain items of plant. So for example, transformers, so sort of 400 kV to 132 kV transformers, or more typically on the data center sites, so sort of 132 kV to 33 kV transformers are now incredibly expensive, at least double what they were 2 years ago. And the lead times are pushing out on those items of plant as well. And I think that it's really the amount of projects going through the system is just causing that price to rocket up. So data centers are competing with solar farms, battery energy storage systems, other sorts of projects to get hold of those transformers, and that's really put the price up. I think some of the other grid-related uncertainty is, like I was saying just now about timescale, and competing with lots of other types of projects in the queue. But I think another issue seems to be the amount of projects in the queue for demand connections, so data centers or hydrogen electrolysis schemes, other really large scale demands like that. So there hasn't been official numbers published by NESO, so the National Energy System Operator, but from what we're hearing, that the queue of accepted to connect demand projects in the pipeline is over 100 gigawatts. So if in context, the peak demand of Great Britain is around about 50 gigawatts. So we're talking double of Great Britain in the queue to connect in terms of just demand projects, and somewhere in the order of 2/3 to 3/4 of those are data centers. So you'll probably know better than I as to how many data centers this country might need, but I'm not sure we need quite that many. So I think there seems to be something of an oversupply of data centers in the pipeline, with more coming in as well. So that very much feels like a government level sort of call to go, hang on, let's take a step back. What's in the pipeline, what's actually needed in terms of, what does GB PLC really want in terms of the amount of data centers in the system, and once some of those projects that are maybe more speculative are no longer in the queue, that will free up a little bit more sort of capacity, spaces to connect and so on for the more viable projects.
Yeah, and I mean the landscape you described, are you aware of, or do you think that into the future, if it's not happening already, that problems relating to grid connection might result in data center projects going elsewhere? I mean, I guess there are power availability in certain parts of the UK, Scotland, I guess, etc. Where perhaps people could, depending on what the data centers need for, even outside of the UK. Is that happening, or do you think that might happen on a scale? Because clearly the government set out it wants to be an AI sort of superpower, but if the data centers can't get what they need and they go somewhere else, that's not a great start to this process, I suppose.
It's not, but I guess that comes back to, again, how many data centers does the government think we might need? So we want to become an AI superpower, and that's a sort of an interesting target for the government to want to try and hit. So I guess if they defined and said, right, what we need is, I don't know, let's give like a number out there, 10 gigawatts worth of data centers for AI in this country, then because we've already got a lot more than that, many times more than that in the queue. It could just be a process to find the ones that are in the queue at the moment that are the most appropriate in the right places, and there is enough capacity in the queue, I suspect, enough capacity in the grid to deliver fairly quickly the data centers that are needed, but it's probably not enough capacity in the grid to deliver 50, 75 gigawatts worth of data centers. So I think it's the balance of going, what do we need? Where do we need it? And it feels at some point that there's probably a government level decision to come in there. And there is a very recent sort of precedent set for that sort of thing. So the government last year published their Clean Power 2030 plan. So that was very much going on the energy project side of things, what energy projects do we need and how many do we need and where do we need them? And so there was probably around about at least five, maybe 6 or 7 times the amount of grid scale battery energy storage projects in the queue than were actually needed to sort of deliver the clean power objectives for the country. So the government set sort of regional capacity levels for batteries that will eventually, and we're just going through this process at the moment, result in a whole load of those batteries sort of not being able to proceed, but only the ones that are ready to do so and in the right place to proceed. So perhaps the government might need to do something along those lines. So yeah, my gut feel is that there's plenty of capacity in the grid to deliver the sort of projects that are needed. It's just trying to define where they should be and how many they should be to make sure that the right projects go forward.
Yeah, and so if I understand correctly, you're basically saying that there are lots of people wanting to do this because they see it's an exciting space, but the reality is that they're all potentially competing for the same business, so you don't need all that capacity. It's just,
Yeah,
as you say, you've got to work out what capacity you actually need and then who's best placed to supply. Is that the situation?
I think so. Yeah, that's what we've seen. And I think there's obviously lots of historic players in the sort of data center developer market, but there's also, I think, quite a lot of new players in the market as well because of the attraction of seeing, the government interest and so on in data centers. I think that's encouraging, in a good way, more people to come into the market, but I guess that leads the market to then become somewhat saturated with schemes. And yeah, so I think the interest is definitely there. It's just trying to sort of refine that and have some sort of optimization process to work out which are the right schemes.
Yeah, and in terms of the sort of criteria for data center developers when they choose location, I guess tradition is, I'm sure it's still the case, grid reliability, resilience, the availability of power, and I guess sustainability is there as well. Is it, I mean, is that pretty much the sort of fairly fixed the traditional landscape? Nothing's changed from those sort of priorities, or?
Yeah, very much so. So data centers will always want a good secure connection. So they'll always be after at least two circuits into the site for redundancy, whereas compared to sort of an energy project, they're often happy with just a single circuit. If their site goes off, well, they can't generate, but never mind. Whereas for data center, it's obviously crucial for them to have power 24/7. So they'll have at least two circuits in, and they'll be looking at the resilience of the substation that those circuits are coming from. So yeah, massive. That's a massive factor. But I guess one of the interesting things is there have been resilient connection options all around the country, but there seems to have been very much a focus on the southeast in terms of data centers. And I guess to some extent is like, where one person goes, another wants to follow. So there's a sort of a follow the leader approach. But West London in particular has been a massive hotspot for data centers, as everyone will know, around Slough. And that's where I guess most of the data centers in the country already are. There's been good grid capacity there. I think from what I understand, good fiber connections and so on. But that grid capacity in that part of the country is now fully allocated, and there's massive new infrastructure builds going in to try and support the infrastructure, the projects that are in the queue in that location. But what's interesting is then seeing now that West London and other parts of London are sort of filling up with capacity. We're definitely seeing data center projects going elsewhere. And there's other AI growth zones, as everyone will know, in different parts of the country. So it's interesting to see that that the sort of maybe restriction in capacity or availability in terms of sort of over the next 5 years has pushed projects to go elsewhere.
Okay, and in terms,
Sorry,
sorry, yeah, no, carry
I
on.
was just going to pick up on the sustainability piece. I guess that there definitely are conversations happening around the possibility of having generation behind the meter of data center schemes. So it could, can obviously a data center can't have enough solar panels on the roof to supply it, but could there be a whole solar farm, on fields nearby that plug in behind the meter of the data center to provide some sort of energy need? Probably wouldn't be everything. But so some of those conversations are definitely happening.
Yeah, I mean, I was going to ask about that in terms of what the data center industry can do to mitigate the sort of current grid challenge. As you say, there's other things that outside of perhaps their remit, but I mean, PPAs have long been used, I guess, to encourage renewables development. Microgrids are talked about more than small scale nuclear, I know, is on the horizon. Do you think all of those are sort of viable options for the data center industry to embrace, to, as you say, maybe not the primary source of power, but at least gives them some sort of flexibility and resilience maybe from the grid?
Yeah, I definitely think that's the case. We're only talking to developers who are looking to connect to the grid. So I don't know whether there are data centers out there who are looking to go completely off grid. I think if you were to go completely off grid, you'd have to have a really reliable set of generation like nuclear and gas, something like that, to run completely off grid. But I think probably more the case it's trying to have the grid connection maybe as a backup, but and then running your generation on site to power you. So yeah, certainly talked with developers about the possibility of solar, particularly to supply some of the energy needs. Um, haven't yet specifically had conversations about the nuclear small modular nuclear reactor option. Definitely going to be coming. Whether we're too early for that yet, because SMRs are still sort of a little bit off the horizon at the moment. And I guess one of the problems with there is not so much an electrical problem, but more of a maybe social problem as to who's happy to have a SMR, close to them. So yeah, I think there's probably a lot bit of a longer tail on the SMRs coming in, but certainly other types of energy behind the meter I think is really going to be quite attractive to lots of data center developers, especially given high energy costs. If you can both tick a sustainability box and tick a sort of reducing your energy bills box by having some generation behind the meter, that's beneficial.
And in terms of addressing some of the things we talked about, I mean, you mentioned obviously perhaps government is best placed to decide actually how much data center capacity the country needs, but I'm thinking more broadly, collaboration from government downwards. Do you think that's quite important? There's a lot of different stakeholders, and they're potentially all heading in the same direction, but maybe don't realize or don't have the conversations that they can actually sort of help each other more, or say whether it's data center industry building stuff off grid, which then can get adopted into the grid, etc. I mean, there's lots of things. Do you think that's the most important thing to help improve the sort of grid resilience and capacity alongside, as you say, government, working out what, because obviously data centers is important, but as we know, the digital world is exploding, so there's more and more
Mm.
power required, when electric vehicles become, every day, if you like. So, yeah, just your thoughts, I suppose, as to how people need to work together.
Yeah, that's a good point. So I guess a few things on that. There are lots of sort of strategic level planning groups going on at the moment. So NESO, the National Energy System Operator, is responsible for most of the sort of strategic grid level developments. So they're running something called the Strategic Spatial Energy Plan. So they're developing that at the moment. So that's really focusing on where energy projects go. So where do we need to, where and how much do we need of solar, wind, batteries, etc. But as part of the mix of developing that, um, they are trying to pick up on things like strategic demand. So, for example, in Scotland, um, wind farms are often constrained from being able to generate because of capacity constraints on the flow from Scotland into England, because the network is not capable of accepting all the flow. So if you could put some data centers or large hydrogen electrolysis plants, or some big demand centers that are up there to actually soak up, as it were, some of the generation, could that help with reducing the amount of network upgrades you need to do? So NESO are really thinking in that space and going, um, how do we best develop the grid? And perhaps data centers aren't just a problem to solve, but actually they could be part of a solution in certain parts of the world. So I think that's really exciting to see that. So and how how does NESO best then predict data centers, I guess that's a real problem because at the moment they might just go, well, a data center is just going to double in capacity. And if we've only got 2 gigawatts or whatever of data centers connected now, then that's only a small increase. But if data centers are going to go up by 20-fold, that's a much different piece. So I think that then comes back to the whole government question of how much do we need and where do we need it? Because that will then not just help individual developers and the queue, but that will also help NISO and their strategic planning. So I think that's one side of the thing is strategic planning. And then I think another side is just data centers working to developers working together to solve common problems, because there are some sort of quite high level problems at the moment. One of the high level problems that data center developers have found is about the voltage level of equipment that they can actually install. So a demand customer in Great Britain can only install up to 132,000 volt kit, whereas these hyperscale data center sort of campuses that are, 500 megawatts onto sort of 1 gigawatt size, these are massive demands, could really do with taking their electricity supply at a higher voltage level. So 275 kV or 400 kV are the highest voltages in the country, but currently they're not allowed to. I know there was a group talking to government a few weeks back about this very issue as to how do they solve this, because actually solving that issue could help accelerate some of the build out of these really large hyperscale campuses. So that was a really good example of some data center developers coming together to talk with government and NISO and Ofgem about that sort of issue, because some of these are, they're regulatory or issues, and maybe sometimes the law has to change to actually make some of this work. So I think if the data center community can collaborate, come together, understand what the common issues are, and work with government to solve those, I think that's really good. And it's been very noticeable that the energy community has done that very effectively. So there are groups like Renewable UK, Solar Energy UK, etc., that are sort of collective voices for those parts of the industry. So I think if the data center community can do the same thing and sort of lobby the government collectively, that's really, really effective.
Okay, and I suppose the obvious final question then is, bearing in mind what we've talked about, are you sort of optimistic that what you've perhaps outlined there in particular will come about in a timely fashion, or do you worry that um before that happens there may be, everyone's panicking about sort of brownouts, blackouts, etc. Do you worry that situation may come about, or you, I say, reasonably optimistic that all the relevant parties will do as required and get their heads together to resolve the issues, or yeah, just your thoughts, I suppose, as to what the future holds.
Yeah, I'm pretty optimistic about it, to be honest, because like I said a bit earlier, I feel confident that there's enough capacity in the grid for the amount of data centers that we're going to need. And even if the grid needs to be upgraded, well, the grid can be upgraded. It's just trying to work out which bit of the grid needs to be upgraded when, in order to get a sort of a sensible pipeline of upgrade works, to allow that to happen. So there's that sort of coordination piece as to what bit of upgrade you do when. But yeah, I feel quite confident that there is enough grid capacity out there, or there can be enough grid capacity developed to connect all the data centers that are likely to be needed. I'm not confident to say that there's enough grid capacity to connect all the data centers that are in the queue, but I think that's a different issue than enough data centers that are needed to sort of supply government ambitions. There's definitely bottlenecks and things that need to be sorted, but it really feels like there's a good focus on the queue and grid capacity and that sort of thing at the moment. And I feel quite confident that, given the right focus, that there was enough capacity available to connect all the data centers we need.
Excellent. It's been great to chat, and thank you so much for sharing so many great insights into what's going on, because it's quite a complicated issue. I know the data center industry constantly says they don't think there's enough power to go around, but it sounds as if in the UK at least you think that's not necessarily the case. But Peter, it's been fantastic to chat. So thank you so much. Thank you.
No worries. Thank you for having me as well.